I'm going to prepare this model for 3D print, and the process is pretty much the same regardless of the manufacturer. So for the 3D print, I know that the plastic moves, the accuracy is pretty good, depending on the printer and the filament and the heat and all of the settings. Uh, but really, we're going to look at this in the same way, same process. So even if I was making this out of aluminum, um, bronze, brass bushings, stainless steel, different materials, I would still go through the same considerations. So one of the items is if I was going to pick what to be stable, to base the other parts off of, I would pick the base. And so that 10 millimeter hole location would probably be a ream, or the one that we say is not going to change by very much. So on the hole basis, the one that's stationary, stable, and then we're going to vary the shafts around the bores. Sometimes it's the reverse, depending on the assembly, but we always go through that process of making those decisions, and there's a lot of little decisions. We already put a relief on the pins so that it would engage and be able um, to come up flush to that edge, and the chamfers on the base and the coupler to be able to dial those in. So now we have to think about what's going to move, the dynamics of this part. So on the whole basis, do I want this to be a running fit where this will spin inside of the base or spin inside of the crank and the follower? And same with the coupler, is which one's going to spin and which one's going to be stationary. So I'm thinking these surfaces, and why did it jump back into my explode? Oh, well, I'm in the explode, so apparently I'm uh, allowed to edit or make adjustments. I don't think my orbit, my no, I don't think anything's turned on. So let's go ahead and in measuring these, if this is 10 millimeters and this is 10 millimeters, that's going to be a light press. It's going to have less chance of spinning than these guys. So of the two, if this is 10 millimeters and this is 10 millimeters, this would also be a light press, but what I can do in making these adjustments, and because it's the configuration, we can do pretty much the same type of thing. I'll open the part. And so again, on this side, I want that to be pressed in, pretty much a transitional to light press. And transitional means that it could spin a little bit, it could be stationary, and that's strictly on the movement of this part. As soon as we inject a power source, a motor, a pulley, a belt, a gear system, then I'm going to have to change my logic to match. So if the base is the stationary, then maybe that gets those items get reversed, so that the shaft that's driving this, the retention elements are able to be put in place to uh, actuate the mechanism. So the other thing of note is that there is no retention as of now. So one of the things I'm going to put in real quick is in the hole wizard. And we haven't done Hole Wizard, so this will be this semester, so we'll do a quick introduction. Hole Wizard, I pre-select the face. I tell it which ones I want, and as a general rule, I don't do the threads on the internal. If I'm 3D printing, we'll take a look at the threads, but most of the time I'm going to have enough wall thickness to put in the minor diameter um, of the tapped hole. So we're ANSI inch, and then be able to use a regular cutting tap to make those threads. So we have counterbores, countersinks, straight hole, or can be used to make dowel holes. The straight tap, pipe tap, or tapered tap, getting into legacy for the Wayback Machine 20 some odd years, but that was where it started, and put in all of the geometry manually. We also have counterboard slots, countersunk slots, and just a straight slot as a hole wizard item. So when we look at these, and we haven't really gone through the thread definitions yet, but if I go with a 1/4-20, that'll be either a button and a button head screw, or possibly a socketed cap screw, maybe a hex. Up to next on the definition, that'll be a decent size to run the outside of the part, and with a washer with the head have good contact and retain the piece. So the 1/4-20 up to next. We can leave the thread call out, the class of thread if we need it. One is then the loosest tolerance. 2 is a standard tolerance. Most threads are going to be in that 2A or 2B, internal or external, external or internal. And 3B are the tightest, and then everything else is pretty custom to the application. So when I place the point at the origin, and we'll get back into select, I can look at the preview, hit OK, and it also takes a little bit out of the geometry, so it's that less to print and weight wise. Want to check the pin short, we're going to do the same thing. So show configuration, since it's not double clicking, or I'm not double clicking in the right place. So the tapped hole gets suppressed. We'll unsuppress it in this configuration so that it participates. Make sure to save it. Oh, and I did not do the holes. Well, maybe we can do that here and have a better sense of which way it's going to go. So if the holes on the crank, the coupler, and the follower, so we say that these are the press, these are the slip, then on both of these, the short pin and the long pin, we'll need those sides to have a minus tolerance. So we can introduce the maximum material condition. So for a shaft, of course, the maximum material condition is the largest diameter on the hole. It's the smallest. Now I got to think what I just said. All right, let's work through it. I'm going to do direct editing for this. We're going to move the face, and I'm going to move it 1/2 millimeter, 20 thousandths. I'm going to make sure this thing can spin. All right, so it also is going to have a little bit of run out, but based on the smoothness, all right, let's make it 10 thousandths, 0.25. So if I flip the direction, we go that way or that way, I can see that the material is being removed to the inside. And now we have a least material condition that instead of the 10 millimeters, we're at 9.5. So one of the things about the direct editing is it's removing it radially, so 20 would have been quite a lot. All right, same thing. I need to make sure that it occurred in both, and it did not, so we'll unsuppress, save it, and I can close it again, or I could leave it. We're gonna have to go through. So if you have material and could print this in its collapsed state, there are printers that can do that. We would have to figure out a best position because there would still be a lot of support material. Yeah, so it'd have to, if we're in the dynamic, oh, I don't have a dynamic right now. If it was in the dynamic, I would need to bring this down to where there's this pretty much tangent to the base so that there would be minimal. I wouldn't want to put support material from the bed all the way up to this just to print it in that position. So if we were to rotate it over, let's go ahead and find that mate. And if I suppress it, and we bring it over so close, I may not even be able to get there with that geometry. So at least minimizing some of the support material. So something like that, or in there. Yeah, it's going to be better to print it individually. All right, so I'm going to do the first one, and then we'll walk through the steps of outputting, and we'll put it in the slicer to see what we can do with the geometry. So I'll open up the base. So it open up each of these parts. Really only need one instance of each item. So we're going to do the file print to 3D. And this is just going to give us those basic settings. So I mentioned before that because of the drift, the droop, the collapse on the print, if I want these to be the roundest holes, I'll print them in the vertical orientation, whereas when the filament's going up the side, it has a tendency to collapse. And not much, but something that would be noticeable. And then we can come down to the save as. If you want to do the preview, there are tools as far as the build analysis where supports might be needed. Have those options available. And I've been using the 3MF, and it always warns me. Oh, I guess it's going to do the 3MF and save. And then the textures and transparency, those don't, it's the disclaimer that says those don't automatically go over. If you're not using material capable of it, you're not going to get it. All right, so we'll pause here and let the Simplify 3D, if you're using Cura or Repertoire or any of the other slicers, it'll be similar. You'll always have that same settings of the envelope, the recipe for the current print, and this is the last print that I did of plugs for the tooling plates. So if we remove those groups, then that will get that out of the way, and I can import. Now going to the drive and my assignments, and we'll find the 3MF. All right, so it goes into position, and if I'm looking at it from the top, then we can move its position. So in Y, it's at minus 21. Let's see what it looks like if I push it out closer to the edge of the bed. I don't want to get too far off, and then if I can get the coupler, crank, and the follower in there, then this will be a complete print. All right, so I've gone through and I've exported the component pieces into the translation files. I've imported them in. I like to keep them kind of close, that there's not a lot of travel. If we do um, the skirt, then well, let's go into the settings. These are standard for this printer with the PLA. Layer settings, the skirt brim. So instead of trying to go around each one, should just make a loop around the whole thing. Infill settings, how much air is going to be inside of each of these. We typically aren't going to print them solid because, well, internal stresses and the heat, and they'll pretty much turn into a banana. And then don't have anything that really needs supports. Temperatures for the extruder, the fans, outputting the code, build volume, what we can fit in there. Everything else that hardly ever pay attention to as long as it's working. And we go ahead and hit OK. All right, so at that point we tell it to prepare to print. And we should go back. Yeah, it's going to be so 5 hours. That's not terrible. And it's going to have to think about that one a little bit. There we go. All right, so if we go through the slice, let's see, from the max to the min, we're going to have to come down quite a ways. We'll start to see that radius right about there, and it builds upon itself rather than just all of a sudden trying to go 90 degrees and overhang. On the top side, really doesn't matter, but it needs to step out and away as it goes through that process. So material cost estimated at $2.50, and the plastic at 55 grams. All right, so we're going to switch back over to SolidWorks and open up the pen one more time. And I'll just make the modification here to the default. So let's get into our default configuration, and all of those should be turned off. And it's in the short, which is fine. So under the whole wizard, then there is a thread, and the problem with printing threads, and we'll kind of see that. We'll take a look at the plug, is that we have to make adjustments, and it always warns you, tool, if you're making something precise, it's only going to be as good as it gets. All right, so we need to find our settings so that it can be an inch tap. It's set to 1/2 inch 13. I want to be at 1/4 inch or 250-20. And the thread location, and still not sure why it's not letting me get a thread location. Thinking about it. So it should find the center. And it's lagging pretty good, so it's having to think about it. All right, I'm gonna go through the settings and pause one more time. Okay, so I had to go back and put the minor diameter in. Usually we'll make the minor diameter a little bit bigger. We're going to see how that affects. It's given me errors before. So the edge is the ID, or the minor diameter edge, face to start. We'll usually offset it a little bit more than the pitch so that we get one full revolution above and one full below. Make sure it doesn't leave a truncated thread. So those are my selections. The offset 2 millimeters, up to selection another 2 millimeters. If we reverse those, it starts inside or finishes inside, finishes outside. Oh, it was still on the inch die, so we'll go back to the inch tap. And the 1/4-20. And there it goes. And there's a little bit of computing power going on here. We're not doing multiple starts. Not worried about trimming with the start face, end face. Everything else should be good. If we can put that in there, we'll see if it completes. All right, so it actually would print that thread, and maybe I'll do one of those. But typically, I'm gonna have to take the tap and run through there anyway. And you know, depending on the accuracy of the print, well, we'll see what we get on that one. So we'll spend some more time with the thread wizard there later on. But at this point, I have enough to be ready to print.